What we're going to do here is look at examples where partial fractions don't work because the degree of the numerator is bigger than the degree of the denominator. So what we're going to do in these examples is we're going to have to start with long division. So if I look at this first example, the numerator is raised to the third, so it's a third degree polynomial. The denominator is just to the first. The numerator has a higher power than the denominator, so we have to start with long division. Long division works like long division worked in elementary school, or if you've done a long division of polynomials, hopefully in a pre-calculus class, then this is going to work the same. If you haven't seen it before, hang on, I'll show you what to do. So we're dividing x cubed plus x by x minus 1. So the x minus 1 is going to go on the outside. The x cubed plus x will go inside the division. And we want to write this as x cubed plus 0x squared plus x plus 0. What I'm doing here is I want to include all of the powers of x starting at 3 and going down to 0. And if there's a term that's missing, I put a 0 with it. So I want the x squared and I want the linear term, and that's why I put the 0 there. And so now how do I do the long division? So I asked myself, what do I multiply x by to get x cubed? That's just x squared. So I'm going to write that over the x squared. Then I do x squared times this expression. So that gives me x cubed minus x squared. And now I subtract that whole guy from the top piece. So x cubed minus x cubed, that will give me 0. I'm not going to write the 0 just because it gets messier. I have x squared minus a negative x squared, or 0x squared minus negative x squared. So that'll give me positive x squared. And then I'm going to pull these pieces down, plus x plus 0. Okay, and now I repeat that same process again. Now I ask myself, what do I multiply x by to get x squared? That's just x. So I'm going to put a plus x. Notice that I'm lining my x is up and my x squared terms up just to keep track of the things more nicely. So now I multiply the x by the x minus 1 to get x squared minus x. Then I subtract all of that. The x squareds will go away because I have x squared minus x squared. Then I'm going to have x plus x because of the minus out here. So this is going to give me 2x. I'll pull the 0 down. And then we repeat the process again. Now I ask myself, what do I multiply x by to get 2x? That's just 2. So I have a plus 2 up here. Now I multiply the 2 by the x minus 1 to get 2x minus 2. And I subtract all of that. So I'm going to get 0 plus 2. So I'm going to get 2 out. Now there is nothing that I can multiply 2 by to get x, or x by to get, nothing that I can multiply by x to get the 2. So this is just our remainder term. So and so what this means is that we can rewrite this fraction as x squared plus x plus 2, and then plus the remainder divided by the x minus 1. Okay, this is something now we could integrate very easily. We would have to do a u substitution on the last piece, but everything else behaves nicely. Okay, and let's do one more long division before we do this in class. So once again, the power in the numerator is higher than the power in the denominator here, so we need long division. So I have my x squared plus 3x plus 2 on the outside. Inside I have x to the 4th plus 0x cubed plus 0x squared plus 2x minus 1, remembering to put that 0x cubed and 0x squared term in there. Now I say, what do I multiply by x squared to get x to the 4th? That is x squared. Then I multiply that x squared by all of this to get x to the 4th plus 3x cubed plus 2x squared. We subtract all of that out. And that's going to give me minus 3x cubed minus 2x squared. Don't forget about that negative out front. It's easy to do. I'll carry these guys down, plus 2x minus 1. Okay, now I ask myself, what do I multiply x cubed or x squared by to get negative 3x cubed? That would be negative 3x. Then I multiply all of this by negative 3x to get negative 3x cubed minus 9x minus 6x. I subtract all of that which means that I'm going to have the first term is going to go away. I'm going to have -2 plus 9. So I'm going to have 7x squared. Sorry, I wrote the wrong powers on those. And then I'm going to have 2x plus 6x. So I'm going to have plus 8x minus 1. Now I ask myself, what do I multiply x squared by to get 7x squared? That's a 7. So I have plus 7. I multiply all of this by 7. So I get 7x squared plus 21x plus 14. I subtract all of that. So now I have 8 minus 21. That's going to give me negative 13x. Minus 1 minus 14 will give me minus 15. The power here is finally lower than the power of the thing I'm dividing by. So this is my remainder term. And so my original expression is just x squared minus 3x plus 7 plus my remainder, which gets divided by the x squared plus 3x plus 2. Okay. For this one, if we wanted to integrate, we're actually going to need to use partial fractions on this piece. So we'll do examples like this in class because they can get kind of messy.